So in this section, we're going to talk about the quadratic function and its translation. So before we do that, we need to talk about the vertex form. So let me write this out here. Vertex form of a quadratic function. So the vertex form of a quadratic function looks like this. Y equals a times x minus h quantity squared plus k. Now you might kind of feel like this looks familiar, and the reason is because when we did the absolute value equations, we had the same type of look where the h and the k had specific meanings, the a had specific meanings. So it's actually the same with the quadratic function. Our a is still considered our amplitude. Our h is still considered our horizontal translation, and it still behaves the same way. Okay, if it says minus, you go right. If it says plus, you go left. And then the k is our vertical translation. So it's still going to do the same thing that we've done before. It's just going to help us kind of tell what it's doing when we're going left and right, up and down. The numbers will give us a big hint on that. So if I could just give you a quick reminder, the letter A, this is our amplitude. And if A is positive, then the parabola opens up. Okay, so if A is positive, then it opens up. If A is negative, then the parabola opens down. So I'll highlight that for us as well. So negative, it opens down. Now that's the A term. The H term. This is our horizontal translation. Okay, so that tells us whether it goes left or right. Okay, so if you see a negative h, then move h units to the right. Okay, and if you see a plus h, a positive h value, so like a plus 2, a plus 7, a plus 1, then move h units to the left. So again, this pretty much looks very similar to the stuff that we did with the absolute value. Okay, so hopefully it's ringing a couple little bells here, and you're thinking like, oh, okay, I know what this is. I kind of get what this is like. Now the k value is our vertical translation. Okay, so our vertical translation. Now, for the vertical translation, it moves it up or down. So if you see a positive k, then move up k units. But if you see a minus k, then move down k units. Now what I'm teaching or kind of reviewing with you guys right now is something that we're going to carry throughout this section and the next section as well. So we're going to actually use this thing for both sections today and tomorrow, and possibly a couple more sections after that. All right, so what we've seen so far, a lot of definitions, but we've seen the definition of the quadratic function in vertex form, y equals a times x minus h quantity squared plus k. And we talked about what a, h, and k stand for. But the thing is, there's also something else that the value of h and k together can give you. So let me give you that information. So if they ever ask you, what is the vertex? Then you just write h, comma, k. Okay, so if you see like a -2 for h, you write -2 where the h goes. If you see a 3 for k, you write a 3 where the k goes. So the vertex is either going to be a high point or a low point of the parabola. Okay, so let me put that right here. The vertex will either be a maximum or minimum point to the parabola. Now the reason why we say maximum or minimum is because the parabola could either open up or down. So the parabola could look like this, where it's opening up, or it can look like this, where it's opening down. So in our case, we would say that this point down here would be a minimum, because it's the lowest point. It has no maximum because the arrows keep going up forever. Whereas this other graph over here has a maximum because that's the highest that it actually goes. But it doesn't have a minimum because the equation, or not the equation, but the graph itself keeps going down forever. So it doesn't have a minimum value, but it does have a maximum value. So again, they could ask you what's the vertex of a function. You could figure it out just by doing hk. All right. Now, if they ever ask you for the axis of symmetry, in other words, where the parabola is symmetric, so axis of symmetry, the formula for that is x equals to h, whatever h happens to be. Okay, so for your homework, they're going to give you some problems in the very first set, 1 through 7, I think it is. Just looking through, yeah, 1 through 7. They're going to want you to state the axis of symmetry and the vertex of each quadratic function. So let me write this out right here. So I'm just going to show you some examples really quick. Okay, these are not from your homework. You're going to have to do all your homework on your own. But here's example number 1. And this is what they're going to want on your homework. So I'm going to kind of list it. They're going to want A, the axis of symmetry. B, they're going to want the vertex. By the way, the axis of symmetry, you might see it abbreviated as AOS, so you guys can do that, AOS. The vertex, and then they want you to tell me if it's a maximum or a minimum. And then they want you to sketch. So it's a lot of information. So we'll try doing 2 of those really quick. And then we'll get to the last set of problems towards the back, the translation ones. Those should be pretty easy, I hope. But these are going to be like the more difficult ones. So let me show you these examples. Okay, example 1, A, B, C, and D. So here's our first one. Okay, so I'm going to write y equals, we'll do x minus 2 squared plus 3. Okay, so I know what I have to find, the axis of symmetry and all that other stuff. But first, let me just draw a coordinate plane. I know it's going to be a little big, but it's okay. Remember, this is all stuff you guys should be putting into your notes. So let's see, just making my tick marks for the graph. Have to figure out the axis of symmetry, the vertex, the max or min, and a sketch. Okay, so let's start off with A. Now the axis of symmetry is supposed to be x equals to h. But if you guys remember, for h, we always write down or do the opposite of what's in there. So since it says -2, I'm going to write 2. Okay, so you always write down the opposite of what you see inside. Now for the vertex, remember it's h, comma, k. We know that h is 2. We just did that. The k is right here. So that's a 3. Okay, so 2, comma, 3. Now for part C, they want a max or a min. Now in order to figure out if it's a maximum or a minimum, you want to look at your A term in the front. Notice how our A term is positive 1. If it's a positive, that means that the parabola is probably opening up this way, which means it must have a minimum value. So I'm going to write minimum. Let me fix that, minimum. Okay, now for part D, we have to graph it. But in order to graph it, it would be really good for us to do a t-table. So I'm going to make an xy. Okay, and I'm only going to pick 2 points. But first I want to graph my vertex. My vertex is at 2, 3. It's right here. Okay. Now my axis of symmetry can be drawn as well. It goes right through the vertex. It's a little invisible line, but I mean, obviously we can see it here. But it's an invisible line that cuts the parabola in half. Okay, now what I'm going to do is I'm going to pick 2 numbers, either to the left, 2x values, shall I say, to the left or to the right of my vertex. Now if you look, my vertex, the x value for the vertex is a 2. It's 2, 3. So since the x value for my vertex is a 2, I'm going to pick a 1 and I'm going to pick a 0. Those are to the left of my point. I could have also picked 3 and 4. Okay, now you don't have to graph all the points that we do, but we want to try to find an extra 2 points just in case. So what I'm going to do is I'm going to plug in a 1 into my equation. So y equals 1 minus 2 squared plus 3. So y equals 1 squared plus 3, which is equal to 4. So I'm going to put the 4 right there. And I'm going to put a point at 1, 4. Now, once I do that, I'm going to try the 0. So let's try y equals 0 minus 2 squared plus 3. Y is equal to negative 2 squared plus 3. So y is 4 plus 3, which is 7. Now you're going to notice that answer, I don't have enough room for it, but that's okay. If I did, I would put it. But since I don't, I'm not going to be able to put it on my graph. So then how do I figure out what this graph looks like? Well, that's where the axis of symmetry comes in. If you notice, I have this point right here on the left side of the axis of symmetry. So what I'm going to do is I'm going to make a mirror image on the right side right here. It's going to be a little perfect copy of what I have on the left side. So now that I've copied it, all I have to do is graph it. So I'm just going to go like that and like that. Now, do you notice, I'm done with this problem, by the way, but do you notice how right here, this is a minimum point, just like I said in part C. So that's how we do one of those. Okay. Now for part B, we're going to do another problem, but this time we're going to make it flip around. Okay. So B, we have y equals, let's try a negative 2 times x minus 1 squared plus 1. We'll do a plus 1, sorry, and we'll do a minus 1 out here, just in case. Let's just try to make it look a little different than the other one. Okay, so I'm going to draw another parabola. So let's see, another parabola right here. And let me put the axis of symmetry here. So let me put the tick marks as well. And then I will get to this problem. But again, you guys already have these graphs prepared for you, but I don't. So part A says, what is the axis of symmetry? So it's x equals to h. Now h is right there, but remember you always write the opposite. So since it says +1, I want you to write -1. Okay, that's your axis of symmetry. For part B, they want the vertex, which is -1 for my h and comma k, right? H comma k. Well, for k, I'm going to write -1. You always write exactly what you see for k, but for h, you always write the opposite. So now that I have that, I move on to C. C says, is it a maximum or minimum point? Which does it have, a maximum or a minimum point? So I have to look at A. Okay, now A is a -2. That means that the graph is going to look like this, which means maximum. So I'm going to write maximum. So there's my maximum value. So now for part D, I need to graph it. Okay, before I graph it, let me put my vertex, so -1, -1, that's right here. I'm going to draw my axis of symmetry, so it's right here. Okay, again, that's just supposed to be a little invisible line that you don't see, but we draw it just to kind of see what we reflect from one side to the other. And now I'm going to do a t-table, okay? So x, y. And I'm going to pick two numbers to the left or to the right of my vertex. Okay, they have to be x values. So notice right now my x value is -1 for that point. So I'm going to pick a 0 and I'm going to pick a 1 for x, because those are two x values to the right side of my green point. Okay, so let's plug them into my equation. Y equals -2 times 0 plus 1 squared minus 1. So I plugged in the 0 going into the original equation. So y is equal to -2, 1 squared minus 1. So that's a -2 minus 1, which is a -3. So I'm putting that right there, 0, -3. So that would be right here. Okay, now remember, you can copy it to the other side of the axis of symmetry. In other words, you can put another dot right there. It's a mirror image. Now we'll plug in a 1. Y equals -2 times 1 plus 1 squared minus 1. So y is equal to -2 times 2 squared minus 1. So that's a -2 times 4 minus 1. So -8 minus 1, that's -9. That means I got to go to 1 comma -9 to draw this point. But again, I don't have enough room, and that's okay. But you always want to try to do at least 2 points. Once you do that, you just connect your dots like this as best you can. And there you go. You have your graph. All right, so for numbers 8 through 15, you guys are going to have to just remember what the translations do, okay? So the parent function of a quadratic function looks like this. So this is the parent function of a quadratic function. So the parent function of a quadratic function is going to be y equal to x squared. That's without any movement, okay? It doesn't move left, it doesn't move right, it doesn't get thinner or wider or anything like that. It's just the way it is. Now, we can write things to make it look different. We can say, well, y equal to x plus 2 squared. Well, that's now a translation of it. Y equal to x squared plus 1. Now that's a translation of it as well. The first one I wrote would be 2 units to the left, whereas the second one would be 1 unit up. So for numbers 8 through 15, they just want you to write, is it moving up, down, left, right? Is it a combination of everything? So just to give you a real quick example of this, I'll do 2 of them, but it won't take too long. I'm just going to say describe the translation. So describe the translation. Here's one of them. Let's say y equal to x minus 2 squared plus 4. And then for part B, I'll write y equal to x plus 3 squared minus 5. So this is all you're going to have to do. When they say describe the translation, you're going to look at your h and your k values. Okay, here's your h and here's your k. All right, and notice how your h value is a minus 2. So remember, the definition I told you was if you see a minus 2, you got to move to the right. So you're going to say moves right 2 times. And then if you look at your k value, it says plus 4. So you actually move up in that one. So you're going to write moves up 4 times. Okay, so there's that one. Now for B, you see there's a plus 3 there. Again, this is your h and this is your k. So the plus 3 means you should move left. So you're going to put moves left 3 times. And then the minus 5 means you're going down. So moves down 5 times. So what I want you guys to do now, after I'm done with this, you guys are going to get your worksheet and you're going to start working on the homework. Okay, you have to do all 16 problems. Start working immediately.